Hi, I'm Adolph Oliver, and this is the video about finding least common multiples. Now, if these numbers were in the bottom of fractions, we'd say we were finding the least common denominator. So the technique is the same, only these are just plain numbers here that we're finding, so we call it the least common multiple. There are two main methods here. The multiples method is the one that's similar to what you do in your head when you have some fairly simple numbers and you're figuring out what the lowest common multiple is. Here's what you do. Let's say we want to find the LCM of 6 and 15. Well, simply what you do is you write down the multiples of both of these guys out a ways and look for the first common number that they hit. Okay, first multiple of 6 is 6. Second multiple we can get by multiplying 6 by 2 or just adding 6 to the last guy. So 12, add 6 to that, we get 18, and then 24, and then 30, and then 36. Now we could keep finding them further out, and we may need to, but let's go back now and find the multiples of the other guy. First multiple of 15 is 15. Second multiple is 30. Oh, look at that. We hit the common multiple right there, so there's no need to go further in this guy. The LCM happens to equal 30. Okay, well, notice, of course, that's a lot less than if we multiplied these two numbers together. What we get, I think, 90. 30 is a lot lower. Finding the lowest common multiple is going to be very important when we get into working with the x's, y's, and z's in algebra later on. Well, let's look at the second way of working the multiples, the lowest common multiple. And this is known as the prime factor method. This is the one that's going to see us through the algebra problems that we have in the future, so we'll be making good use of it. See, 16 and 18, you could work out the multiples like we did up above, but it'd be a little bit messier to do it. When the numbers get a little bit larger like this, or there's maybe 3 instead of just 2, or there are variables in it to boot, then what's good to do is to turn around and work this with the prime factors method. And the main key here is what you do is you prime factor both of these guys. Now, we talked about factor trees previously to be able to find prime factors, but you can also break these guys down in your head and keep breaking them down until you get to nothing but primes. Then that is the prime factorization. For instance, 16 we can think of as 4 times 4. Well, each of these 4s is 2 squared, so I got a 2 squared for the first 4, a 2 squared for the second. Now, of course, remember how we handle the exponents. We got the same base 2, so we just add the powers. 2 plus 2 is 4. Now, if you think about this, take the first two 2's. 2 times 2 is 4, times the next one. 4 times 2 is 8, times the last one. 8 times 2 is 16. You can see that that's the correct factorization. Well, 18 is just 2 times 9. So there's a single 2 to the first power. And 9, of course, is 3 squared. So here's what we have. I've got all the different bases that we want to work with here. So let's talk about how we find the LCM. Once you have prime factored these guys, and here they are, 18 is 2 times 3 squared, 16 is 2 to the 4th, then the process to get the LCM, you look back at these prime factorizations and you take all the different bases. The bases are the big regular number, the powers are exponents, so the little guys up above. Any base that you see, you write down in our final LCM list. If it shows up more than once, like these 2's, you only still write it down once. So just all the different bases. So I see 2's, I also see a 3. Okay, well, those are all the different bases. Now the last thing I do is I go back and I take the highest power that I see for each of these bases. This is 2 to the first power here, 2 to the fourth here. So I'm going to take 2 to the fourth. 3 only shows up once, and it is squared, so there that is. Well, okay, what have we got here? Remember, 2 to the fourth, of course, is 16. We know that 3 squared is 9, so multiply these together, and that'll give us what our LCM is. 6 times 9 is 54, carry the 5. 1 times 9 is 9, plus 5 is 14. Looks like our LCM here is going to be 144. Now that again is less than these two guys multiplied together. Well, let's get a little more practice at working on these guys. First, the multiples method with things that are fairly simple. So here we are again. Find the LCM of. Now notice this. 4 and 5 do not have any common factors. 5 is just made out of 5. 4 is 2 squared. So when you have a situation like that, the best you can do is just multiply the two numbers together. But let's prove that. Okay, so here we go again. Remember now, these are simple guys, so we're going to be using our multiples method. Okay, first multiple of 4 is 4. Add 4 to that, you get 8. Then 12, then 16, then 20, then 24, and we could go further, but let's see if that hits it. Multiples of 5. First multiple of 5 is 5. Add 5 to that, you get 10, then 15, then 20. Ah, there we go. Okay, we hit 20, so the LCM here equals 20, and that's what we knew because there were no common factors. 4 times 5 gave us the 22, but most of the time they're going to be common factors and the LCM is going to be less than just multiplying those. Well, here's the next one to try. 8 and 12. Okay, once again, the multiples of 8 and the multiples of 12. First multiple of 8 is 8. Add 8 to that, we get 16. Add 8 to that, we get 24. Add 8 to that, we get 32. Add 8 to that, we get 40. Add 8 to that, we get 48. Well, let's see how we do with 12. First multiple of 12 is 12. Add 12 to that, 24. Ooh, well, there we are. Don't need to go any further. The LCM equals 24. Notice that 8 times 12 would be much larger, like 96. So again, we want to be finding the lowest common multiple because when we get into the algebraic fractions, that's going to be very important. Well, one of the things we can do, of course, if the numbers are fairly simple, we can also think of, 3 of them, let's say, 5, 6, and 10. So again, if I'm going to use the multiples method here, let's get everybody set. First multiple of 5 is 5. Add 5 to that, we get 10, and then 15, and then 20, and then 25, and then 30, and then 35, and let's see if that's enough. 6. First multiple of 6 is 6. Add 6 to that, we get 12, and then 18, and then 24, and then 30, and then 36. Well, we see there's a common 30 here, but it's got to be common for all of our numbers, including the 10 down here. So let's get to multiples of 10. 10, add 10 to that, I get 20. Add 10 to that, I get 30. Yes, indeed. Turns out that 30 hits all of these. So the LCM of all 3 of these is 30. Now, if you multiply these numbers together up here, you get 300. So this is definitely a big improvement in terms of the lowest common multiple. Well, now when we've got some things that have some variables and also, more numbers and stuff. Here we go. We're going to use the prime factor method on these. And so we want to find the LCM of 5x squared and 15x. Well, here we go. 5x squared equals, and 15x equals. Well, 5 is prime, so we don't have to break that down anymore. And the x squared, well, the beauty of the variables is they're already in prime factor form. Just write down x squared. Now, the 15 here is 3 times 5. So this is going to be 3 times 5, both to the first power, and then another x to the first power. Okay, here's how you find the LCM with these guys. The LCM equals, you go back and get all the different bases you see. For the numbers, I see 3 and 5. Remember, if it shows up more than once, you still only put it once in the list. So 3 times 5. Then there's only one variable, x. Here it is. Well, okay, before you do anything else, go back and get the highest powers of each. All the numbers are to the first power. So that's how we indicate first power for them. The x's, however, notice there's an x squared. Well, what's our LCM going to be here then? 3 times 5 is 15. And then x squared. There it is. Okay, well, let's do the similar thing with the next guy here. Okay, I've got 4xy cubed, and I've got 8y squared. Okay, first off, the 4 is not prime, but it's 2 times 2, or 2 squared, which is prime. Remember, of course, you always have to indicate the exponents. That's what makes this whole process work. We got a single x, so to the first power, and we got y cubed. Get the next guy down here. 8 is made out of 3 2's multiplying each other. 2 times 2 is 4, times 2 is 8. So this is 2 cubed. And then, of course, the variables are nice. You just write down the y squared. Okay, what's the LCM going to equal here? Well, for numbers, we only have the base 2. And for variables, we have x and y. Remember, only write them down once, even if they duplicate. Okay, now, what's the highest power we see? Well, let's see, 2 is squared here and cubed here, so 2 cubed. X is just to the first power. Y is squared here and cubed here, so the highest power is 3. Okay, well, what's our LCM? 2 cubed is 8. We have a single x. You can leave the power off or put the 1 if you really want to. And then y cubed. Okay, there is our LCM. Well, let's look at one last example here where we've got 3 terms here that we're working on. Again, prime factor, when it starts getting variables and things like this, much safer to use the prime factor method. So 10ab cubed is going to equal 15b squared is going to equal, and then 20 a squared b. Okay, well, 10, to break it into primes, 2 times 5 gives me 10, and those are both primes, so 2 times 5, I've got, and they're both to the first power, a to the first power, and then b cubed. Remember, the variables are the easiest. They're in effect already prime factor. You just write them down. 15 is 3 times 5. So 3 times 5, both to the first power, and then just b squared. And then the last one down here, 20, is 4 times 5. 4, of course, is 2 squared times 5. That's 4 times 5 is 20. And then the a squared b. Okay, Well, here are all the prime factorizations. What's the LCM going to equal here? Well, first go back and get all the different bases. Let's see. For the numbers, I see 2s, 3s, and 5s. So remember, if it shows up once, put it in your LCM list. If it shows up more than once, you still only put it in once. Then the variables, I see A's and B's. Now go back and take the highest power you see for each. Here's 2 to the first, but here's 2 squared. So 2 squared is the highest. 3 only shows up once, and that's to the first power, so there it is. And 5 here only shows up to the first power. Now the A's, I've got A the first, but A squared, so we take A squared. B, I've got B to the first here. B squared, B cubed is the highest. Okay, well, what are we going to have here when we put these all together? Well, remember, 2 squared is 4 times a single 3 times 5. 4 times 3 is 12. 12 times 5, 60. So for the number part, we get 60. Now, of course, the rest of it here is real simple. Just write down the variables with their powers. So here it is, 60 A squared B cubed.